In this module, we will look at the basics of optical transmission. In this case, the binary encoded values are carried by optical signals. The transmission is carried out as follows. Consider the transmission of the letter A once again, that consists of 1 and 5 zeros and a 1 from point A to point B. To carry this information, we will generate light pulses that are of different wavelengths. In this case, the first light pulse will have a wavelength of W1, whereas the second light pulse will have a wavelength of W2. The third one will have a wavelength of W2. These are light pulses as opposed to electronic signals. In this particular case, there is a duration for the light pulses as well. This again will be called the pulse duration. We also follow a certain convention in this case. First, the wavelength of W1 indicates that we are transmitting the digit 1. A wavelength that is W2 indicates that we are transmitting the digit 0. In the case of electronic transmission, the signals are carried by copper wires. In the case of optical transmission, however, we use optical fibers to carry the light pulses. There are different methods of generating the light pulses. One is to use a laser to generate the optical light pulses. The other option is to use a light emitting diode to generate the optical pulses. Therefore, by either using lasers or LEDs, one may generate digital optical signals that could carry the values of 0 and 1. In a number of instances, we had to interface optical signals with electronic signals. Consider, for example, a computer that is transmitting information. The information that comes from the computer is in the form of electronic signals. It needs to be fed into a device that can convert electronic signals into optical signals. These optical signals are then carried by fiber optic cables to another device that would then reconvert the optical signals into electronic signals that could now be fed into a computer for further processing or for receiving the signals that originated at point A. The devices that may be used for the conversion are as follows. If we were to convert electrical signals into optical signals, of course we can use a laser, or we could also use an LED. But on the other end, we need to convert the optical signals back into electronic signals. In order to do that, we may use a device such as a photoelectric cell. A photoelectric cell generates electricity when light is shown on the cell. So this is one device that could be used for converting optical signals back into electronic signals. Now let us look at briefly the principles of the optical transmission in terms of the light rays traveling along fiber optic cables. In general, we have studied in high school physics that light travels in a straight line. Then in this particular case, how does light travel along a cable that may be bending at certain points along its path? The explanation is as follows. Consider the case of a vase that you would find in a gift shop. This vase is filled with fibers, and the tip of these fibers glow because of the fact that there is a light source kept at the bottom of the vase. This is one of the ornamental material or ornamental things that is kept in a gift shop. In this particular case, the light source at the bottom of the vase traveled along the path of the fiber and it came out of the tip of the fiber. That is the reason for the glow at the tip of the fiber. This indicates that light can travel along the path of the fiber. How does it take place? It takes place as follows. Consider this fiber optics cable. The light rays that are shown into these fiber optic cables can travel by bouncing around the periphery of this cable. The way the fiber optic cables are constructed, it will allow the light rays to reflect at the boundary so that the light ray is contained within the cable itself. There are different techniques that are used in the transmission of light rays within a fiber optic cable. The three dominant methods of transmission are: number 1, multi-mode; number 2, multi-mode graded; and number 3 is single mode. In the industry, however, people view optical transmission as being divided into two different modes. One is multi-mode and the other one is known as the single mode. The way the signals travel in the case of multi-mode transmission is as follows. The signals bounce along the boundary of the cable in a rather haphazard way to reach its destination. Obviously, this is not one of the most efficient methods of fiber optic transmission. In the case of multi-mode graded transmission, the signals bound in an organized manner to reach its destination. The bouncing in this case is not arbitrary as seen in the previous example. Therefore, the multi-mode graded transmission is more efficient than the multi-mode transmission itself. Yet a more powerful and a better method of transmission is known as the single mode transmission. In this case, to the extent possible, the rays travel straight across the fiber cable. Whenever the fiber cable bends, it will reflect and then try to travel along the path of the fiber. In this particular case, the bouncing of the light ray is minimized. As such, single mode is the most efficient form of transmission in optical transmission. The highest speed is usually made possible under single mode transmission. At the same time, the single mode transmission is also more expensive to implement compared to the other two modes of transmission.